Ladies and gentlemen, the petrol engine cylinder block is reinvented. Cast iron with the same weight as aluminium. This is a joint Tupi presentation with the partners Sintercast and Ricardo Engineering for the Vienna Motor Symposium 2022. We like to show you that cast iron is the best choice for an inline passenger car engine. Please see the authors of our paper. More than 2 million engines with compacted graphite iron are produced per year globally. The bore reaches from 83 mm to 980 mm and the power output from 240 kW to more than 80 MW. The reason to use CGI are the extraordinary properties in comparison to grey cast iron. We have more than 75% higher strength and more than 45% higher stiffness and more than 100% higher fatigue strength. Over the last 20 years, CGI has become the standard material for V-diesels and commercial vehicle blocks and heads. Tupy is the global leader for CGI production. Tupi has a high-volume series production for CGI engines since 2003. 7 CGI installations in 3 countries. More than 20 components in series production for petrol and diesel engines, from the weight 20 kg up to 420 kg. More than 125,000 tons per year shipped CGI castings and full machining capabilities to deliver machined components to our customers. Why do we still use aluminium engines in passenger cars? Okay, the density and weight of aluminium is attractive, and we have a relatively good thermal conductivity, and this is especially interesting for cylinder heads. Everything else is a compromise. Strength, stiffness and fatigue is limited. We need cylinder liners or surface treatment. The metal volume must be large and so the breathing areas are limited. And the life cycle energy and CO2 footprint for aluminium is challenging. The Nvh behavior is limited and we have cost issues. Now the question is, what if the cast iron cylinder block was the same weight as aluminium? This question we will answer with a joint development project together with Sintercast and Ricardo to build a demonstration engine and to prove our concept. We selected as base engine a 1.2 liter series production spark-ignited engine, and we changed the crankcase material from aluminium to CGI. We took the CGI component as a main structural part and covered it with plastic casing. Now let us have a look to the base engine. Here you see in this picture the crankcase and the bed plate, and together with the caps, this base engine crankcase has a weight of 21 kg. In comparison, you see the CGI block, ladder frame, casings and caps. CGI crankcase has the same weight as aluminium crankcase. The additional results are 54% less material, and this gives a better situation for the breathing areas which could be increased. We also have a same or better Nvh behavior. Now let's have a look to the components of the Tupi CGI engine. Components A, D and E, the cylinder block, the ladder frame and main bearing caps, are casted in CGI. We have the thin walls and we have the possibility to increase the stiffness with fracture split caps. The component B and H are produced by PA material. The casing incorporates oil galleries, oil cooler mount, oil pan and timing case. And component H is the ventilation module which supports the blow-by behavior of the crankcase to the cylinder head. Component F is a steel plate closing, and G, the oil seal, is taken from the original engine. The upper seal is produced by FPM material. Now let us have a look to the new CGI crankcase. Now I would like to do a comparison of the different materials which we have in discussion. You see that the comparison of aluminium to normal grey cast iron and to CGI. Here the grade 450. Cast iron and CGI 450 have higher mechanical strength as aluminium. The thermal conductivity is for aluminium the best in this comparison. With regard to thermomechanical fatigue strength, CGI 450 has by far the best values. Please see the alternative tensile strength values on the right side. For aluminium and grey cast iron we have 250. And for CGI, we have 450 megapascal minimum tensile strength. To meet new demands imposed by engine evolution of our customers to reach higher performance density, Tupy has successfully developed CGI 500. Now we are ready to offer grade 500 as a standard product. Here we have 500 megapascal as minimum tensile strength, with a comparable thermal conductivity and still good machinability. In the special case of our ultralight concept, the thin walls and lightweight of the crankcase resulted in fast cooling, enabling us to achieve a minimum of 550 megapascal in tensile specimens sectioned from the casting. The casting process leads to controlled low nodularity in the near of the cylinder bore walls, which is very important for the engine properties. This provides thermal efficiency, dimensional integrity and wear resistance. Low nodularity gives the best combination of mechanical strength, thermal conductivity, tribology, castability and machinability. Please see the details of the left picture. In the region of the piston rings, we have low nodularity values between 8 and 11%. The cylinder block and the ladder frame castings were produced in volume production environment. The individual cores were assembled to form fully enclosed core packages. Metal filters and running systems incorporated directly the core packages were placed into green sand flasks on the standard production line. The sand cores used conventional silica and resin compositions. In comparison to that, the cerebred ceramic with increased resin content was used to ensure the robustness of the 2 mm thick interbore war jacket core, and this jacket core had a height of 25 mm. Following the coating process, the interbore water passage was 2.5 mm thick. The machining process was similar to the volume machining of Tupy and was performed without any problems. Another important technology to CGI is the fracture split situation, and this makes it possible that we have applied on main bearings a perfect assembly situation and superior Nvh results. We would like to show you the stages of development in this slide. It started with the selections of ideas, creating a basic concept model, followed by an optimization process which was supported by modern design tools. The next process steps were the design for manufacturing stage, taking into account volume production requirements, combined in parallel with simulation loops for mechanical and thermodynamical properties. Finally, the prototype parts were created and the proof of concept was performed in specific tests, and this completed the development project. Here you may see as an example various Cgi design variants developed with the use of UptiStruct and with different load conditions, including firing, bending, and torsional loading. The block design was iteratively modified to produce an architecture that provided the same stiffness as the original aluminium block. The design was analyzed for bore distortion and ring conformability and for head mounting stresses and local stress concentrations. Here you may have a look to the evolution of the Cgi cylinder block with closed bed plate in the beginning to a production-ready design with fracture split main bearings and a Cgi ladder frame. The dyno test bench investigation finalized with a 100-hour high-performance test run. And here we reached the same performance and the same fuel consumption as the base engine, and we showed the functionality of the Cgi concept. The bore distortion analysis performed at hot assembly you can see in this example. It shows the distortion of the Cgi engine in comparison to the base engine, and it is in the given range of the base engine. In addition, the Cgi design offers potential to even reduce the distortion. The noise, vibration, harshness Nvh testing delivered the comparison of the Cgi engine to the base engine. The block torsion and especially the bell housing frequencies of the Cgi engines are more than 4% higher than the frequencies of the aluminium engine. And the frequencies of the bearing caps are between 18 and 46% higher than the values of the aluminium base engine. And this expect the significantly better Nvh performance for the Cgi engine. The development of the project showed the proof of concept. Ladies and gentlemen, the petrol engine cylinder block is reinvented. Cast iron can have the same weight as aluminium. We have seen the full functionality of the Cgi engine. Similar weight than aluminium and superior Nvh results. In addition, we have the benefit that we see a significant carbon footprint reduction to produce the iron blocks. In the manufacturing phase, we have 40 to 70% lower CO2 emissions in comparison to aluminium. Our spark-ignited engine with a CGI crankcase enables the roadmap for future fuels, for biofuels or other synthetic fuels from renewable energy sources. Also, we can reach highest power densities and low weight, which is very important for conventional and hybrid powertrains. The next step is to apply this new technology to a customer engine to evaluate the potential of a specific application. Ladies and gentlemen, you have seen, cast iron can have the same weight as aluminium. The Tupi ultralight iron engine is ready to go. Thank you very much for your kind attention. We are looking forward to your questions.